Hey, in this video, we are going to be moving on to our next concept, and our next concept is going to be looking at mirrors and lenses. Before we do that, we have to talk really quickly about the ray model of light. This is going to apply to both our mirror lessons and our lens lessons. So a little bit about light, a little bit what we know about light. Light is going to travel in straight lines. Because of this, we can use light rays, lines and arrows to show the direction and path that light takes. So essentially, we know that light is coming from the sun. We know that light is traveling in a straight line. We're going to pretend that's straight. And we know it's got directionality as well too. So what we're going to be doing is we're actually going to be predicting light hitting a surface. And we're going to be predicting what that is going to look like in terms of an image. So we're going to use light, these straight lines to represent light. And we're going to use little arrowheads to represent which way the light is coming, because we want to make sure that we're looking at the light traveling in one direction. A few definitions that I want to look at really quickly. The first one is called geometric optics. This sounds really similar to the name of the unit. Geometric optics is the use of light rays to determine how light behaves when it strikes an object. So again, we're going to be using light rays, and we are going to determine how they behave when they first strike a mirror. And then we're going to look and see how those light rays are going to behave when they strike a lens. I'm going to be referring to this idea of incident light. What an incident light is, it's the light that is emitted from a source and hits an object. So we're not really going to talk too much about the sources right now. We really kind of talked about that before in our types of luminescence note. So we're just pretty much going to assume that all the light is going to be coming from the sun. When we do a lab later on, we are going to have our own source of light in our classroom. I'll talk about that then. A little bit about the types of objects that light can hit. There's three different ways that we classify types of objects that light can hit. You've actually heard about them in grade 9. The first term is transparent. What a transparent object is, the material that allows light to pass through easily. Objects can be clearly seen. So examples of transparent objects are things like glass, water. So it's something that you can very easily or very clearly see light through. They allow all light to pass through. Translucent. That's something that you might have seen around your house. Translucent object is a material that allows some light to pass through, but the rest is either absorbed by the material or reflected back to the light source. Examples of translucent objects are things like frosted glass, ice, because you can't see an image clearly through ice, or even if you have a really thin piece of paper and you hold it up to the light, that could be a translucent object as well too. So with a translucent object, you can typically see the outline of the image, but you can't see details or features of the image. The last type of object that light can strike is called opaque. Again, you should remember this from grade 9. An opaque object is no light can pass through that material. All light is either going to be absorbed by the material or the light's going to be reflected back to the source. Object cannot be seen at all. So essentially, one of the themes for this unit is that light is what causes us to see objects. With no light, there's going to be no object. So if you're trying to shine light through an opaque object, it's not going to go through. You're not going to see any sort of image. Examples of opaque objects include mirror, wood, doors, anything like that. All right, so again, we're going to be talking about light passing through objects or hitting objects and the image that they form. What I mean when I say image is a reproduction of an object through the use of light. We're going to start by looking at mirrors. A mirror is any polished surface that reflects an image. An example might be a lake on a still day, polished metals, or clear glass. Mirrors, you probably didn't put a lot of thought into how a mirror is built, so I actually have a pretty cool how it's made video as well too that's linked at the bottom here. I would take a look to it. A lot of people don't realize that mirrors are actually totally opaque in the back. There's no light that transfers through, and it's reflecting all that light back. So you might want to watch that how it's made video so you can really get an idea of understanding what the composition of mirrors are and how it actually causes all light to be reflected back. Here, I'm going to zoom out just a little bit. This image here has a lot of important terminology. So I actually want you to make sure that you either save this image in your notes or you copy this image into your note, because I'm going to be using all of these terms. So essentially here, we have our source of light. I said our source of light, we're gonna assume it's the sun. Here it's a flashlight. In the lab we do later, that source of light is gonna be a candle. So here we've got our source of light, and we can see the light rays traveling in a straight line. And you can see that we've actually included those arrowheads to show where the light is traveling. We call this the incident wave or the incident ray. This ray or wave, this light ray, is gonna hit an object. This object here is a reflecting surface. So remember, we're starting to talk about mirrors. So mirrors reflect light back. What's going to happen when that light is reflected back is this incident ray is going to bounce off of this mirror. It's going to again keep traveling in a straight line, and it's going to be perceived by your eye. Notice here we have a straight line, we have an arrowhead, and we call this the reflected ray. That reflected ray is because it was reflected off of this surface. Notice that we also have a dotted line. We call this dotted line either the normal or the perpendicular. The dotted line is because it's imaginary. So we actually just use it as a tool of measurement. So when you look at a mirror, there's no dotted line in the middle of it. What the normal is it's a line that's 90 degrees to the surface of the mirror. So here's our mirror. That normal or perpendicular is perpendicular to the mirror, 90 degrees. What it helps us to measure is it helps us to measure the angle of incidence and the angle of reflection. So the angle of incidence is going to be the angle between the incident ray and this normal. So you can see this angles here. It could be a really big angle if the light ray's coming in like this. It could be a really small angle if the light ray's coming in like this. We also here have the angle of reflection. So again, the angle of reflection is between the reflected ray and the normal. Here you can see the angle of reflection. It could be a really big angle of reflection. It can be a really small angle of reflection. These measurements allow us to make some assumptions and some predictions. So it's important to understand what I'm talking about when I say angle of incidence and angle of reflection. So just a little bit of terminology around that diagram. That normal was the perpendicular line to the mirror surface. Our incident ray is the original incoming ray. Our angle of incidence is the angle between the incident ray and the normal. The reflected ray is the ray that bounces off the reflected surface. So again, make sure that you have that ray diagram saved somewhere in your notes. It is an important diagram. Now we're going to look at some of those assumptions I just talked about. These are the laws of reflection. So essentially there's two laws of reflection that we're going to follow when we look at mirrors. The first one says that the angle of incidence is always going to be equal to the angle of reflection. So here we've got our angle of incidence. So whatever angle the incident ray hits the mirror back, it's going to be reflected at the exact same angle. This isn't just true in light, it's actually true in everyday life as well too. Rebound shots, when you're golfing or in basketball, that's why there's that little square around the basketball net, is because the angle of incidence, the angle at which something hits a surface, is always the angle at which it's reflected back on. The second one that we're going to look at, it's a little bit harder to comprehend. The incident ray, the reflected ray, and the normal all lie in the same plane. So all that means is the incident ray, the reflected ray, and the normal are all in the same plane. Picture them as a 2D image. So not a 3D where you've got like an incident ray hitting this side of the mirror and the light reflecting out of this side of the mirror. It's all in the same plane. It's all in the same 2D spectrum. A little bit about types of reflection as well too. We have two different types of reflection. We're going to be focusing mostly on specular reflection in this unit because it's so much easier to study. So what specular reflection is, it's reflection of light off of a nice smooth surface, so a really polished surface. We're going to be looking at plane mirrors, but another example of specular reflection is still water, a flat piece of foil. So anything where your image doesn't look distorted and you can clearly see yourself. Diffuse reflection is reflection of light off of an irregular or a dull surface. So maybe a sheet of paper, water with waves, or a crumpled piece of foil. What happens in diffuse reflection is you don't necessarily get a clear image. Incident rays are parallel to one another, but angles of incidence are going to differ. Angles of reflection would be different. Reflected rays would not be parallel. So this is just explaining why diffuse reflection might look weird. It's actually a little bit better in the next diagram. So we're going to take a look at this. In specular reflection, when we have that nice flat surface, notice that my incoming rays are parallel. Notice that my reflected rays are also parallel. That's because it's a smooth surface, we're not hitting any bumps, and they're very nicely being reflected. In diffuse reflection, again, we have that bumpy surface. So in diffuse reflection, what's happening is we have everything's coming in parallel, but notice it's not leaving parallel, right? This is hitting here, it's hitting a bump, and it's going off in this direction. This one's hitting a bump, it's going off in this direction. So because these lines aren't parallel, because they end up getting scattered, this is why your image isn't necessarily clear. So again, this is the difference between this crystal clear lake here, specular reflection, nice smooth surface, and here notice these trees look pretty blurry. That's because this is diffuse reflection. It means that the surface of the water must be a little bit rougher. So now what we're going to do is we are going to take these angles, these rules, sorry, that's where I was going. We're going to take these rules and we're going to be applying these to our plane mirrors, and then we're going to look and apply these at curved mirrors.